Hi everyone, this is Vlad again, and today we're going to do a ServiceNow and database automation platform demo. So first, let's take a look at the legacy operations of a database administration department. So what we have on the left of the screen, we have some intake agency that, for example, whether it's ServiceNow for project management, it's JIRA, or there's some AI um, device or functionality that takes information from the user and then it sends it, opens a change request or incident and basically sends it to or task and sends it to a database administrator. So the admin usually is experienced in one or two or sometimes more than that database technology, but not more than that. Sometimes there is a separate department for SQL Server, from Oracle, and so on. So their knowledge and experience is not interchangeable. You have to keep DBAs on the payroll that can do only certain things, but not all of them. That's basically related to different vendor or technology. So that's kind of conventional automation. The DBAs can use certain automation tools for the job, such as some basically products from BMC or from Oracle, like OEM or Cloud Control. But the point is, you do need a database administrator to kick off the job or uh, to write the code and things of that nature. Without the GBA, that conventional open loop automation doesn't work. So what we're going to demo is different. It's called closed loop automation, which basically is the same thing. There's an intake agency, also takes writes down documents what needs to be done or what needs to be fixed. But instead of a person, it basically sends it via an API to a think of it, it's kind of a jukebox that instead of music, it plays, it replays different tasks or it resolves the same issues. But certainly there will be no uh, database administrator. So this part, we basically can delete it. And this is what it actually looks like. Um, so the automation node is nothing more than just a really cheap Linux machine. And this shows what that machine uh, contains. So the machine could have like 8 CPUs, maybe 68, maybe 120 gigabytes of RAM. But what's important, it basically has three components. Number one, it's Ansible playbooks. That is the logic that actually runs the automation. They're written in YAML. Then we have some wrapper shell scripts, and those basically point cron, which is the scheduling utility, points cron to specific playbooks. So cron could have an entry for a wrapper script number one, which would basically monitor um, database, for example, creation script. That will be the wrapper script, which basically would be connected to the playbook. So three components: the scheduler, the shell scripts, and the automation playbooks. So the automation itself works basically this way. So let's take a look at, let's see what it looks like. So let's find so what we see over here is it's basically it's the automation platform. So what it is a workspace within ServiceNow in this iteration. There's another demo I have for JIRA, which is related to project management. This one is related to ServiceNow, which means tasks, incidents, and also change requests. So usually the user opens up a change request. It would go to a living person who would do some work and then go back to the change request and close it. Here we have this situation. The user also goes to the same service now, but they would basically pick which activity needs to be done. For example, password needs to be changed, or application user needs to be created in all or some databases, or schema needs to be refreshed from one database to another. This one refreshes lower environments databases, for example, development UAT from production one. So there's a drop decommission database, a fixed performance, which runs AWR on request for certain periods of time. So there's just running scripts, applying Oracle patches to databases, then provisioning database, upgrading collection of databases could be 1,000 to, let's say, 26 AI. That's what this one does. But the point is the user would pick which activity has to be performed. For example, change database password. The person clicks on it, and basically, here's what happens next. This explains what this particular utility or intake form does. So this explains it changes database user database password, and it posts the new temporary password in the nodes after execution. So this is automation logic. So let's do just that. Let's change the database user password. So here's the example. So to change a password for user Serium, you simply type CDP. That's the name of the project. And then let's change my name, be Gregorian. Then we click on submit. So once again, this is a workspace within ServiceNow. We click submit, which takes us to the actual ServiceNow template. So it's a regular template. The only difference is it's basically assigned to a hyper automation platform, which is kind of a machine. It's not a person, it's a machine. So as you can see, it says identity type, not human, it says a machine right there. So basically what happens next, we need to do is to click schedule. For different types of requests, there are different types of approval. For destructive, irreversible change request, the user will have to click on request approval. It will go to management approval. Then, if necessary, it will go to the cab approval. But the point is something that is dangerous. There will be a lot of hoops basically to jump through. But here, all we're changing is basically the password. So all we need to do is to click schedule, and that is it. So now we'll wait and see what happens. So if we'll take a look again at the architecture diagram I showed you, we saw there are three components. So the cron utility scans this URL for the ServiceNow and asks every 60 seconds, oh, I'm sorry, I need to click implement. Otherwise, it's not going to do anything. So schedule implement, but the point is it scans this URL and asks, okay, is there anything that it has been approved? And it does that every 60 seconds. If there is something, again, it checks for approvals and then checks for the parameters. And parameters you've seen. CDP is the name of the project and the username is V. Grigori. So then it detects it. It basically gets the relevant automation playbook and gets to work. So any second, it will actually reset the password for me in all of the databases, and then it will post all the information over here. So as we can see, it started to work. No, not yet. Okay. And then there we go. So it says Hyper Automation Platform, and now you see it even closed the change request. So it jumped through everything within 90 seconds. It took us 60 seconds to detect, probably 3 seconds to execute, and another 2 seconds to, or 10 seconds to actually execute it. And then it basically updates the change request. So it says, okay, V. Gregorian, temporary password is this, database is reset in is names of the databases, dev, UAT, seed, STG, cert, and production. So reset by hyperautomation platform and a timestamp. So that is basically an example of one script run. If we'll take a look at change request history, and you, by the way, you can find this workspace for database automation platform by going either to favorites. Of course, you have to place it in favorites first, or simply searching for database automation platform, and you're there. So let's try another. Well, actually, let's take a look at the change request history. And so all of these were executed by automation platform. We know that because they're already closed. And you can see that project names and parameters are in the short description. So let's take a look at the few. So this one is DDP, which is decommission, I believe. Let's see. So confirm drop, yes, it's decommissioning of database. So it went through all of the stages of authorization, including the CAB approval, because dropping a database without a backup is reversible. It's a dangerous activity. But in any case, it does that. It takes a snapshot. So it started at 3:31 and finished at 3:31. It took exactly 10 seconds to execute this work. So let's take a look at something else. Upgrades. Um, so let's take a look at this is patching. So let's see what happened in patching. So again, a user went to the uh, platform, entered pat, which means patching, then pipe, then the name of the server to patch, to apply the patch on, then the name of the container and the number of the Oracle patch. So what happens in this case, automation goes to Oracle support site, pulls the patch, downloads, applies, and this activity takes probably a good hour. So this is LS inventory. So let's say 7:30, 12 o'clock, and it started at 12. So 12:15. Well, actually, it was pretty quick. In any case, so this is patching. All right, so let's go back for let's take a look at the rest of them. So for everything, every activity that fails, automation opens up a spin-off change request for the DBAs this time. What they are basically, they're being sent to DBA queue for DBAs to connect and investigate why the automation couldn't do what it was supposed to do automatically. So that's why it says DBA repair required. So auto upgrade halted on this server. And of course, it uploads the logs why this failed, and we can see already database was not available, or we can take a look at the logs, and the logs will also tell us basically the same thing. Oracle not available. And here's the full log. And here's the location, Oracle home, and everything. But once again, let's go back to to the platform workspace. So let's pick something that is really destructive. For example, DDP, which is decommissioning database. So here it's a different story. So to detect, it's 1 minute or less. To complete, 10 minutes or less. But there is a notice destructive and irreversible. So not only we have to type the server name, container database CDB1, and pluggable database, let's do test DB. Now we also need to type confirm drop test DB to drop it. And click submit again. For this one, the request approval, we first request management approval. So this go to somebody else's queue. And that person will have to approve it, and there are two such queues. So one is manager approve. Ordinarily, person who submits would not be approval. It would be his or her manager or another group manager. Then, if it's necessary, there will be CAB approval. So request CAB approval as well. And also, that's a separate team who will also have to approve it. Only then there's an option to click basically to do implement. And now we'll wait again for 60 seconds for the work to be completed. I'm not really sure if there's such a database, so probably it will fail because the database doesn't exist. So also, this platform gets parameters basically live from the server. So usually you have to get, for example, a list of databases that are running. But by the way, here's the automation workflow. Actually, it is a lot. This is simplified version. There is a lot of steps, maybe 100, maybe 200 steps. It's just there's no space to put them here. But this kind of explains the steps. But in any case, usually you have to pull the name of the database, where it resides, whether it's supported or not, which version it is. It's not necessary in the platform because it gets all the metadata live. So if we want to see which databases there are, and by the way, let's check if testdb exists. No, it doesn't. So that CR will fail. But in any case, this tells you that database named UAT runs on LNX01. And that basically is the most recent metadata, which it takes the trip immediately when we click on this. So this particular change request, as purpose explains, generates an AWA report for a period of time, and then runs SQL Tuning Advisor and opens a CR with the DBAs to consider the implementation of the suggestions made by the SQL Tuning Advisor. So let's take a look at one of those. So change request. Let's see if there's any PRF. Yeah, here is one. Let's see what it suggested. So this was run on 7/29. So it says automation will find. All right. So did it find anything? Yes. It says PRF analysis complete. Top CPU consuming SQL for the period, and here's the period we enter. So it didn't find any suggestions for these three SQL IDs, but for one, a profile was suggested. And of course, it opens up a change request with the DBAs with all this information about the tuning session with the execution plan before the implementing the suggestion and after with the scores, with the execution plan, basically everything. So the DBAs can make an informed decision whether or not to actually implement this. So that's pretty much it. The number and the complexity of the change requests is basically increasing. I'm adding more and more um, intake forms and YAML playbooks to actually execute this. But this is a kind of a quick look at how a database automation platform operates. Thank you for your attention.